Hello, hello, hello. Am I audible to you all? Hello, hello. Is my voice audible to you all? So I think today's session would be like shown on a different UI kind of a thing. I think you will be seeing the whole screen. Okay. Okay. I think screen is also visible wide apart, right? Right. Like things are being cleared on a. Is not that. Is this okay? I think it would be perfect now. Just tell me yes or no that is this thing okay? That things are clear? Okay, okay. Now you will not hear because I am also having my video started up here. Okay. Now echo will not be there. Okay. Now echo would not be there. Okay, because I think there is some offsetting in the StreamYard due to which this particular interface you are able to see. Okay, right, right, right. So I think we can start the session. Okay. 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 So today's our topic would be. Today's our topic would be what do you say? The memory management, right? So I'll be looking at the chat section from my own phone. Okay. So would not be changing much the screen. Okay. So yes. So we'll be starting the session. That is the memory management. So when we started the OS, the main there were two three pillars that we saw that what OS was doing. That it was actually scheduling the processes for us, right? It was helping us to maintain the concurrency. Okay, it was helping us to maintain the concurrency, right? And it was helping us to avoid the deadlock condition. And the fourth condition that it was providing us is that the memory management, that we are what you say we are actually maintaining our process in a such a way that there is a proper isolation and as well as a efficient memory management. Okay, because see, memory management is an what you say important aspect for any kind of operating system, right? If you are not able to manage your memory in a perfect way, then it would lead to what you say a non-efficient system, right? Okay. Okay. So, so we'll start that. So we know that memory management is an important aspect of any kind of operating system. Okay. So this was the introduction of memory management. Okay. So any doubt till now, like what is memory management, and any doubt from the previous class? Okay, you can ask in the chat section. Okay, because then we will start about that what is logical addressing and the physical addressing. Okay, so don't worry about like the nodes, though in the nodes will be having all these things. Okay, just understand that the thing. Okay. Okay, so there would be like two things in the memory management. That first would be logical addressing and physical addressing. This particular thing is directly asked in the interviews, that what is logical addressing and what is physical addressing, right? So there is a very good example that I'll share with you. Okay, so you can just see this picture, that what is logical addressing, what is physical addressing. So in simple words, a logical address is one. Okay, a logical address is one which is generated by CPU, because it is logical, so it will be definitely generated by CPU. Okay, and this particular logical thing which is generated by CPU uh, passes through something that I will tell you that through what thing it passes. Okay, it passes to something and get translates into physical addresses. Okay, into physical addressing, physical PA, what you say, physical address. Okay, and physical address is the actual address which is actually showing us the real position in the main memory, or you can say the secondary memory, like how it is stored in the hardware. Okay. Okay, so the physical address is the one which is actually showing that how the things are stored in our main memory, or you can say RAM or anything else. Okay, so this was about the physical addressing and logical addressing, right? And now we will see that how OS provides us with that particular thing, the isolation thing, and how the logical and physical address thing would be more clear to you by this example that I'll be giving you. Okay, so suppose there is a process P1. Let me zoom in. Okay, so there is a process P1. Okay, P1 which is of 16 KB. Okay, suppose 16 KB. Okay, 16 KB. So it will be starting from 0 and it will be going from 15 KB. Okay, this would be clear in your mind, or 16, you can write it anyways. From if the indexing would be from 1, then it will be from 1 to 16, but we often take 0 as the base address. Okay, we often take this as a 0 based in the indexing, so it will be from 0 to 16. Okay, so 0 to 15. Okay, sorry, 0 to 15. So this particular process, when it will enter our system, it will pass through OS. Okay, it will pass through OS, and in the physical memory, and in the physical memory, and in the physical memory, or you can say the hardware, it will be stored something like from here to here, like P1. Like suppose our physical memory consists of 0 to 100, 0 to 100. So definitely there is no surety that it will start from 0 here. Okay, so, there might be a thing that there's something else here. Okay, so what will happen, it will gain a 16 KB difference. Okay. Okay. So okay, see, the screen is in portrait mode, but I think there is some setting that has to be changed from the backend, and I don't know how to change it. Okay, so I thought, but what it showed, that your the screen would be purely visible to you, right? The shared screen. Okay, so that's why I thought to start the session. Otherwise, I thought that I would cancel the class, but I know this thing that it would show you the full screen in the shared mode. Okay, so what I was telling, so from 0 to 15 there is a process P1, but how it will be stored here, it will be stored something like from 128 till 144. Okay, so it will be stored something like this. It will be stored something like this. Okay, and this is happening due to OS. And what particular thing in OS due to which this particular thing is happening is MMU, that is management unit. Okay, so this particular memory management unit actually caters two things. Okay, it actually sees two things, that whether there is a space available, two things, that whether there is a okay, that whether the space available in the main memory or the secondary memory, or you can say that, or you can say that this process P1 is not accessing any illegal area, or you can say that it is not going into area of other process. Okay, so before starting, like on the first day, what we saw that OS provides us the isolation, right? The one of the main thing that OS has to perform is the isolation. Okay, so if there is a process P1, okay, and there is a process P2, we have to maintain them in the same hardware in such a way that P1 is not interfering in P2 and P2 is not interfering in P1. Okay, so how will this particular thing happen? This particular thing will only happen when we have a perfect memory management unit. Okay, so what this memory management unit will see, right? It will see that there is there is, what you say, what's the length of the program, 0 to 16. It will check space available, like there is a 16 KB space available. If yes, it will say okay, you can just put that particular program in the main memory. Or otherwise, what it will check again, it will check again that suppose there is this, from, what you say, 156 to like other things. Okay, to suppose, okay, it is let's made of is 1000 KB. So this is starting from 156 and ending to 158. So the other thing that this memory management unit will cater off is that while that P1 should always remain from 128 to 144, right? It should not go for, suppose, like if we are adding P1 at 144, it will going to definitely access some of the memory of this allocated area also. Okay, so let me just made it with some other color. So this would be in a red area. Okay, because this is allocated to someone else and you are allocating itself to you. Okay, so this particular thing would lead to, like, what you say, distortion of the isolation property. Okay, so this is also the work for the memory management unit. And you can ask your doubt till here. I am looking at the chat section from my phone, because what is happening, if I am actually going from StreamYard to this, it is actually showing a blurry screen. uh, so you can ask your doubts, if you have any kind of doubt. uh, I don't know, I think there's might be some setting issues and I don't know how to, like, do them. Okay, how to correct them. But I think screen is not that bad. Okay, when I'm sharing the screen, you are able to see the full screen. Okay, only my, what you say, full photo is not available. Okay, See, you have to manage for today, okay? But today's lecture is also very theoretical, so you can just listen also, and afterwards, if you see the what you say, if you see the notes, it will be clear to you. Okay. So I think we can move on. If you have any doubt in this, please ask that. Okay. I think screen issue would be there in today's class, but that's not the case. But just ask me any doubt that you have related to this. See, how will you means that's why OS is there, right? Okay. Okay, so someone just asked that when you teach us, tell us how to implement this practically. Okay, so why you need to do it practically? Because OS are there to do it practically, right? This whole subject that we are doing is that to understand, yes, there are complexities, underlying complexities within the interaction that can happen between user and hardware. And that's why we introduced OS. So we are actually the main core that you are studying is that there are difficulties, and you are just seeing that how OS resolves them. Okay, so this is why you don't do it practically. Okay, uh, right. So this is a theoretical subject that you have to like keep in your mind that these are the difficulties that OS can face, and this is how it resolves itself. Okay. So this is all about the logical addressing and physical addressing, and you can see that how memory management unit is doing all of these things. Okay. Okay. So I think we can move forward. So what you saw that there was OS who was actually having the memory management unit, and what was happening when the process is entering, it is actually doing something, and it is actually allocating this in the hardware or the main memory. Okay. So I'll tell you one thing again, that what is the difference between a logical addressing and the physical addressing, the main difference. Okay. So the logical address, I'll refer it as LA. I'll refer it as LA. Okay, logical address. It is generated by CPU. Okay. It is generated by CPU. CPU will say that I want this process to be executed. Okay, it will say I want this particular thing to be executed. So it will generate a logical address that I want a logic, it will generate logical address for a process P1 because it wants a P1 process to be executed. Okay, after that there would be a memory management unit, or you can say translation would happen. Translation of this logical address will happen, and it will find this particular what you say P1 process in the hardware or the main memory. Basically they'll find in the RAM, because there or you can say the secondary memory, SM. Okay, from SM it will say yes, this is present, and it will be loaded into RAM. It will be loaded into RAM, and from RAM, that is random access memory, it will load it into CPU. So I think the difference between physical memory and the logical memory is clear. That logical memory is actually seen by you. Okay, this is seen by you, or you can say it is generated by CPU. But physical address is not something that you can. Okay, so physical address is something. It is not something that you can directly access. It is the what you say work of MMU or OS. They'll decide what to do. You have generated the logical address. They will find it and will cater to your needs. Okay. So any doubt in this, that what is difference between logical addressing and physical addressing, you can ask. I'm looking at the chat section, and then we'll move forward. Okay, because there are two ways in which you can allocate the memory. that is contiguous memory allocation and non-contiguous memory allocation. We'll look into it, right? Okay, because because it is very simple topic. Okay, and we'll also see that how the free space, that is the free space that is left during these all, okay, during these all what you say processes, that how that free space is also managed. Okay, so you will be provided notes after the session. Okay, so just tell me that any doubt till now, because then we'll move forward. Just say yes or no in the comment section and then we'll move forward. Okay, so I think we can. Okay, okay. So you'll be issued that. Let me know when after I think 4 or 5 days they are issued. Okay, so I think we can move. Okay, so you will see that how the address translation is done. I just told you this is like a more good representation of that how it is done. That from the CPU logical address would be generated. Okay. Okay, so I'll tell you that what is the meaning of this limit register and reallocation register. Though I have covered these, but I have not provided the specific terms that these should be. So what I just told, that the process P1 was of 16 KB, right? Okay, 16 KB. So this limit register actually is the one which will store the 16 KB. 16 KB in it. Okay, it will store 16 KB in it. Okay, and the reallocation register will see that after adding that particular 16, after suppose someone asked I want 16 of P1. So after adding the 16, that it should not be accessing that illegal memory, right? That illegal memory, that it would not be overflow the memory, or you can say it is not accessing the memory area of any other process. Okay, that I just show you here, that this is the work of the memory management unit, or you can say address translation, that it should not be accessing the memory of any other process. Okay, so this is what actually represented here. Let me zoom in so that it is more clear to you. That so that suppose now CPU wants 5. Okay, and let me add here also that here is a P1 which is actually allocated P1 from 128, from 128 from 128 to what is the addition of 16? I think 144. Okay, because it is of 16 KB, so from 128 to 144 it will be P1. Okay, so what this reallocation register would be storing, it will be storing 128, 128, 128 to 144, to 144. This is what the reallocation structure would be having in it. Okay, so now what will happen when CPU will generate I want 5 of P1, I want the fifth location of P1. First of all, it will check from the limit register that is this particular demand which is generated by CPU, is it less than the limit register? It will say yes, it is less than, so it will move forward. Okay, suppose there is a 17 that it is asking, so you know that already that our process was of 16 KB and it is actually demanding the 17th KB of the P1. Okay, it is actually demanding the 17th KB of P1, so this will not happen. And what will happen, that once this condition is false, you will go and error will be shown to you that this particular address you are demanding is not of P1, so you cannot get this. Okay, or this particular thing is not available with us. Okay, So this was about the limit register, and after that what will happen, it will add this 5 to this 128, uh, and it will check, yes, is it less than 144. It will say definitely it will be less than 144, and what will happen, the fifth position from 128 will be given to you, because this is what was demanded. Okay, so okay, wait a minute. So this would be given to you. So the fifth location would be given to CPU. Okay. Any doubt in this translation? Because this was the like very basic. But if you have any doubt, you can just ask me. I'm looking at the chat section now. Okay. Okay, nice. If all these things are clear, then nice, very nice. Because we are just very end of our session. Okay, because if you learn this, that how the translation is happening. Okay, and I think this point would be clear that okay, I'll definitely go one more time, that if this thing is clear, that how the reallocation register and limit registers are working, then that particular thing in your mind, that how the isolation is provided, that P1 is not actually interfering in P2, P2 is not actually interfering in P1, how that particular thing is working. Okay, we saw that this is one of the most important feature of what you say, this was a very important feature of OS, that it provides memory isolation, right? So you can see that how it is providing that particular isolation. Okay, nice, very nice. I'll just go once over it because someone asked. I think rest all things are clear. Okay, nice. Okay, I will once go again. So suppose there is a 16 KB process of P1. Okay, I'll definitely share the notes. Okay, I'll definitely share the notes that will be provided by DevTown team. Okay, so what is happening? So 16, suppose this particular thing is already stored. Okay, and now what happens? CPU demands fifth position of P1. So limit register would be storing a value of 16. Okay, because by the name you can say it is actually referring to the limit. And what is your limit? Your limit is 16 KB. So first it will look at the limit register, and it will ask whether this particular value demanded is less or more. If it is less than 16, then you will say yes, and what you will do, you will addition. Are you able to see there is a plus sign? Then what will you do? You will take the base address from the reallocation register, add this particular 5, and you will get the fifth position of P1, and it will be provided to CPU. This is just about the thing. Okay, and now one more thing. Okay, now I think this would be clear in your mind, and now we will look at what is contiguous and non-contiguous memory allocation. Okay, by the name it would be clear that the contiguous means, let me zoom in first, zoom in more. Okay, and by this pictorial representation it is also very much clear, I think. Okay, but I'll also explain that what is difference between contiguous and non-contiguous allocation. Okay, so we will start with the contiguous first, that what is contiguous, and then we will move to non-contiguous allocation. So the contiguous allocation means simple, that that this is your memory area. So this is your M area. M referring is the it as M. Okay, so there is a process P1, P1, and there is a process P2, P2, and there is a process P3. P2 also there. So what happens in a contiguous memory allocation, that these all processes, without any fragmentation of these processes, they will directly get into this, okay, and find their spaces. Okay, so P1 would be directly here. Okay, so this is 1. This area would be captured by 2. Okay, and this area would be captured by 3. This particular area would be captured by 3. So this is what about the contiguous memory allocation. But what is a disadvantage of this particular, what you say, what is the disadvantage of your allocation is that there are free spaces that are available in this, and these free spaces now cannot be allocated, right? Because what is happening, there would be left 1 kb. Okay, this free space would be of 3 kb. Suppose I'm just letting it, okay, this is just an hypothetical situation. This particular would be of 2 kb. So see, there is a very much kind of a fragmentation is forming. We will learn that what is internal and external fragmentation. But are you able to see that there would be memory wastage in the contiguous memory allocation? Okay. Ne- okay, so just tell me about this, that if you are clear about the contiguous memory allocation, then we'll move to non-contiguous. Okay, so this is also happening in this particular thing. If you are able to see in the contiguous memory allocation, so this would be P4. This would be P4, not P3, because this happens in the non-contiguous. That same process is actually divided into 2 3 parts and allocated at different spaces. So what is happening? P1 is actually allocated the full block, not like the in a fragmented way. P2 is actually given full block, not in a fragmented way. Similarly, P3 is also given full block, and similarly P4 is also given the full block. Okay, so just tell me that this particular thing would be clear in your mind, that this is the contiguous memory allocation, and there is a, what do you say, there is a disadvantage that the free space is always there. Okay, and this leads to fragmentation. Okay, and what kind of fragmentation? External fragmentation. And that we will see that what is that external fragmentation in the upcoming, like as we move forward. Okay, so just tell me that this thing is clear in your mind, that what is contiguous memory allocation. Okay, I think nice. Yeah, this would be clear. Okay. Now you can definitely think that what would be the case in the non-contiguous allocation. Okay, now I'll tell you. Uh, okay, now I tell you that what is this non-contiguous allocation. With a very good example. Very good example. Okay, just think that there are these spaces, 1 kb, 1 kb, 1 kb, 1 kb each. 1 kb, 1 kb. So these all are of 1 1. Okay, these all are of 1 kb, 1 kb, 1 kb. Okay, so on till here. These all are of 1 kb. Now what will happen? Suppose there is a process P2, so of a P1. Okay, there is a process P1. What you will do, that this process is of 3 kb. This process is of 3 kb. Okay, so what will you do? You will divide this into 3 parts of 1 kb. So what will happen? That it will lead to 1, 2, 3. It will lead to its 3 fragments of 3 kb, of 1 kb each. Okay, 1 kb each. And what will you do is that you will allocate them in these. Okay, someone here, suppose this particular P1 one would be here. This 2 part will go here. Okay, this 2 part will go here, and this 3 part will go here. And in similar manner, as the more processes comes, what you will do, you will allocate them, and you will also mark them that this is a first part of P1. Okay, this is a second part of P2. Okay, and this is the third part of P3. right? You will also, oh, not P2, this is of P1, this is also of P1, this is third part of P1. You will also identify them as this, as I mentioned. Okay, so you can see that similarly when more processes will come, they'll all will get in, and there would be no spaces left. Okay, or you can say there is a minimum spaces would be left in it. Okay, so this is what the non-contiguous memory allocation is. Okay, but what happens in this, you have to maintain a page table, or kind of a table which will be referring to all of the frames which are here. Okay, because you are seeing that that this particular P1 is actually disintegrated into three parts. That one here, second part here, and third part here. So you have to make kind of a table thing, from which you will look again and again, and you will see that where is that particular P1 one part is there, P1 second part is there, P1 third part is there. Okay, so what happens that you have to maintain a table here, and when the CPU will be asking, it will be referring to this table before accessing them. Okay, so there is a very good question that is asked, that which is good, uh, a contiguous memory allocation or a non-contiguous memory allocation. And the answer is very much simple to it, that it depends upon on your trades off. Okay, that how you want the trade off to be happen. You want the trade off to be happen on the basis of the spaces, like if there are spaces left, okay, that will lead to external fragmentation, or you will lead, or you will maintain a table which is also a very heavy operation, right? You will maintain a table here, you will maintain a table here. Okay, let's just wait for 1 minute. That you will be maintaining a table here, and you will be calling it on it again and again. Okay, so there is, that choice depends upon you, whether you want, whether you want this particular fragmentation to happen, but your overall processes would be fast, or you want the memory management to be efficient, but what will happen that your table would be formed, and each time CPU will look into this table for its operations. Okay, okay, attendance link can't open. Let me just see. Okay. Yes, I think it's not also copying it. Okay. Let me just ask them. But I think we should go. Let me. Let me just ask them, and then we will continue with the session. I think it's not opening. Right. Okay. This is the link that is being given. Okay. Uh, let's just wait. Okay. Just don't write anything in the chat section for a minute. Okay. Just wait. Let me just try. I'll be giving this in the chat section, and just wait. Okay, just wait for a minute. Okay, just wait for a minute. Don't just write anything. Okay. So just wait for a minute. Okay. Right. You can just screenshot it, and then, or you can do one thing also, right? You can just type this particular URL in your Google, right? Just wait for it. You can also do one thing, that you can write this full URL. It's not a big URL, right? It's not that big URL. You can just right. I was also thinking the same, but I thought that that particular thing would not be also working. Like like the form is not there. I thought that particular thing, but it was opening in from my end, right? Okay, so we are just at the last of our session. So you can just screenshot the particular URL, and you can either do that particular Google Lens thing, or you can just write this particular thing in the like by manual typing in your. Just wait for a minute. Just wait for a minute. Okay. I think many of the people are able to fill, but I don't know why some are not able to. But let's just finish this thing first. Okay. So the last topic was this, that how these Okay. Okay, just wait for a minute. Just wait for a minute. Let me see that what is going on. You'll be provided the link. Okay. Okay. The thing that you can do is that I'll definitely share it with you again. But the thing that you can do is that you can just take the screenshot and can type the URL, right? That would be more fine, right? That would be fine for you, right? Let me just take the URL again. Uh, it will be working, right? Because it's working for me. Why it will not work for you? See, some of the people are able to do it. Okay, just wait for a minute. Don't write anything in the chat section. I'll be giving this particular thing to you. Okay. Okay. See, wait for a minute. Just type this. I'm sharing this. Just type this particular thing here. That if you are able to see in your what you say in your yes. So the team has already received some responses, like 200 responses are already been submitted. Okay, so type this particular thing in your this particular what you say link in your URL in the Google, and it will definitely show you up. Okay, so the link is perfectly working. Okay, I even also typed in my Google and I opened it, right? So the link is working perfectly fine, right? Link is perfectly fine, right? So someone told that it typed in Chrome and it works. Definitely it will work, right? You are actually okay, right? Yes. Okay, okay. So this is the thing. I think the attendance issue is resolved. Okay, I am extending the link for you so that you can just fill out the form. Let me share. I think the link is been here. Okay, it has already been shared. So you can do one thing, that you can just type this particular. See, it is already there in the chat section. If you open the YouTube, it has already been pinned by the DevTown. Okay, you can just type this particular thing in your. Okay. See, you are not able to click, right? But if you have done with the attendance, then you can leave, because it is not clickable for right now. You can just take the screenshot and just write this particular URL in your Google section, and it will open. It will definitely open. Okay, it was purely theoretical session. So no project for this. Okay, do try to open this particular link in what you say in your like the PC, right? Just go and take the screenshot, or on the Google Lens you can type this, or you can give it to the chat GPT, right? See, you are seeing that link is not working. Already we have got the 200 plus responses. Okay, no project, no project is there. Okay, if you have fill the form, then you can definitely leave. Okay. See, if you will be trying to like what you say going through this. See, if you are clicking for the link from here, then I think it will not open. Uh, but if you'll write this in your URL section, it will definitely work. Have miss see let me resolve that doubt that if not working link. Okay. Do try to write this link. Okay, so I think it's opening in my end. From my end, I don't know uh, from your side what's happening. So, but do one thing, that try to do this thing in PC. It will definitely work. Okay, it will definitely going to work. Okay, so just try to do. I'm waiting for 5 minutes more. Then okay. My PC, this link is working, right? This would be working. Join through PC, that definitely it will work. Okay, I'm just giving you 5 minutes more because it's working from my end in my PC. I have another PC installed here. I have just run this particular thing and it is working. I don't think so. It is working on mobile if you are going through this. Okay. So okay. Okay. There are no projects, okay, for this. Okay, you can leave if you have filled the form. Okay. So this is a very small topic that I have already explained, but these are the terms that you can also like look into it, right? They are not heavy terms. Okay. Okay. I am giving you time, right? So someone tell that I typed and it worked perfectly, right? You will get certificate after submitting this 5-day attendance and all. Okay, goodbye. If you have like done with the attendance, I think most of them have done because it was 200 when the attendance link was given. Now it is 74. Okay, so I think uh, I think I may end this session, right? Because most of the people have filled. Okay, because some are saying that I typed and it worked perfectly. Okay, okay, goodbye. Okay, so the thing that you have to do is that I'm just take the screenshot of the link and use it. Okay, type it in the URL, it will perfectly work. Okay, notes will be provided. Don't okay, the notes will be provided. Okay, so goodbye, everyone. Okay.